Designing the enterprise branch. Enterprise branch and teleworker design. This section describes design considerations for the enterprise branch and enterprise teleworker architectures. Enterprise branch architecture. So recall that the Cisco enterprise architecture, based on the Cisco SONA, includes branch modules that focus on the remote places in the network. So enterprises are seeking opportunities to protect, optimize, and grow their businesses by increasing security, consolidating voice and video and data onto a single IP network, and investing in applications that will improve productivity and operating efficiencies. Now, these services provides an enterprises with new opportunities to reduce costs, improve productivity, and safeguard information assets in all their locations. The Cisco Enterprise Branch Architecture takes into account the services that enterprises want to deploy at their endpoints, no matter how far the endpoints are or how they are connected. Now, on this figure here, it illustrates how branch services relate to other parts of the Cisco Enterprise architectures. So you've got the branch one or branch of one, branch, campus, branch, and so on. Enterprise branch architecture. The Cisco Enterprise branch architecture, illustrated on this diagram here, is an integrated, flexible, and secure framework for extending headquarters applications in real time to remote sites. The Cisco Enterprise branch architecture applies the SONA framework to the smaller scale of branch location. So common network components that might be implemented in the enterprise branch includes the following. So first, you've got the routers providing WAN edge connectivity. Okay, switches providing the LAN infrastructure, security appliances defending the branch devices, and wireless access points for device mobility. Characterizing the branch. So enterprise branch design. So requirements differ with the size of the branch offices. Consider the following questions when designing the enterprise branch. So first would be, how many branch locations need to be supported? Second would be, how many existing devices, including end users, hosts, and network infrastructures, are to be supported at each location? The number of devices supported is limited by the number of physical ports available. Okay. Next would be, how much growth is expected at each location, and therefore, what level of scalability is required? Next would be, what are the high availability requirements at each location? What are the level of security? Okay. Should the security be managed locally or through the central location? Are there any requirements for local server farms or network between the internal network and the external network? For example, in a demilitarized zone or DMZ. Okay. Next would be, should the network management be supported locally or via the central location? What wireless services are needed? And how will they be used by the clients? What effect will the network and the environment have on the wireless devices? Okay. And then the last one would be, what is the approximate budget available? So the key point here is, branch offices can be categorized based on the number of users. Okay. So a small office up to 50 users using a single tier design. For medium office, between 50 and 100 users using a dual tier design. And for large offices, between 100 and 200 users using a 3-tier design. Small branch office design. So small branch office designs combines an ISR access router with layer 2 switching and end user devices, phones, printers, and so forth. Okay, a typical design is illustrated on this figure here. Okay, so you've got WAN services. WAN services are typically provided by a T1 primary link. The internet is used as a WAN backup accessed by an ADSL connection. Okay, now for the network services, the EIGRP routing protocol is used. So high availability across the WAN is provided by the floating static routes across the ADSL internet connection. And the QoS mechanism include the traffic shaping and policing, okay, and the implementation of the scavenger class of traffic applied on both the switch and the ISRs. Now for the medium branch office design, a typical medium branch office topology is illustrated on this figure here. Okay, this is similar to the small office topology, except that the WAN edge devices are larger. Typically, 2 routers were used here. Okay, and the access switches for LAN connectivity are external stackable switches. Now, for the WAN services are typically provided by a private WAN, for example, with dual WAN technology. Okay, so in this example, well, the old frame relay links, you've got the network services, okay, like the use of the EIGRP routing protocol. High availability across the WAN is provided by dual routers running router redundancy protocols such as HSRP or the hot standby router protocol, VRRP or the virtual router redundancy protocol, and the GLBP, which is a gateway load balancing protocol. So QoS mechanism, okay, used include traffic shaping and policing, and the implementation of the scavenger class of traffic applied on both the switch and the ISRs. Now for the large branch office design, in a typical large branch office design, as illustrated in this figure here, dual ISRs are used for redundancy at the WAN edge. So firewall functionality is provided by dual adaptive security appliances or the ASAs, and dual multi-layer switches, stackable or modular, are deployed at the distribution layer. Now for the WAN services, in this typical design, provided by an MPLS network with dual connections. And network services, EIGRP routing protocol is used. So high availability across the WAN is provided by dual routers running the redundancy protocols such as the HSRP, VRRP, and GLBP. You also have the ASA, failover functionality, and object tracking. Now, the QoS mechanisms used include traffic shaping and policing, and the implementation of the scavenger class of traffic applied on both the switch and the ISRs. Comparison of teleworking options. Now, in contrast, enterprise teleworkers can be differentiated from other forms of a work at home or telecommuting scenarios, in that the emphasis is on delivering seamless, managed accessibility to full range of applications and services critical to the operational effectiveness of the enterprises. Okay, as shown here in this diagram. Now, the Cisco Enterprise Teleworker architecture is part of an overall secure Cisco Enterprise architecture infrastructure. It accompanies the capability to integrate and securely manage their remote workers within the corporate network while simultaneously providing a high quality end user experience, supporting a full range of enterprise applications for the enterprise teleworkers. The enterprise teleworker typically connects to an ISP through a DSL or cable modem or broadband and might use an analog dial-up session to back up this connection. The enterprise teleworker solution is implemented with the small ISR routers, okay, so with integrated switch ports connected behind a broadband modem, as shown in this figure here. Okay. Now, this solution uses a transparent, always-on VPN channel back to the enterprise. So within this architecture, centralized management means that the enterprise applies security policies, pushes configurations, and periodically tests the connection through the broadband, cloud, and back to the corporate office to determine the latency, jitter, and packet loss experienced at any time. This solution supports advanced applications such as voice and video as part of the full suite of enterprise services for the end user. For example, a teleworker can access a central office IP telephone system from home with comparable voice quality and can thereby take advantage of a higher function IP telephony capabilities instead of using the PSTN. So an alternative solution is an unmanaged VPN approach in which the end user implements a software VPN from a PC across a generic broadband router, access point, and hub appliances. This solution typically cannot support the level of feature integration, the quality of service, the managed support needed to reliably deliver the voice, video, multimedia, and traditional data to the end user, but it might be appropriate for occasional remote users with lighter application requirements. Designing the Enterprise WAN summary. So the Cisco Enterprise Branch Architecture provides enterprise services to remote users. You should characterize each branch location to develop a suitable design. So a small branch office design typically uses a single one-access router with 1 or 2 access switches to support up to 50 users. Medium branch office design typically uses 2 one-access routers with multiple access switches to support up to 100 users. Large branch office design typically uses 2 one-access routers, 1 or more multi-layer distribution switches, and multiple access switches to support up to 100 to 1,000 users. An enterprise teleworker design can use a small ISR with integrated switch ports and an always-on VPN to support one teleworker. Designing remote connectivity. So remote connectivity design review. So analyze the network requirement. So type of applications, the traffic volume, and traffic patterns. Redundancy and backup is necessary. Characterize the existing network and sites. So technology used, the location of hosts, servers, terminals, and other end nodes. Develop WAN and branch network design. So select a WAN and branch technology to support the requirements. And select hardware and software components to support requirements. Now, to summarize the module, designing remote connectivity, network application and connectivity requirements influence WAN design. The Cisco Enterprise MAN and WAN architecture provides integrated QoS, network security, reliability, and manageability on private WANs, ISP service through site-to-site and remote access VPNs, service provider managed IP or MPLS VPNs. The Cisco Enterprise Branch Architecture supports small, medium, large, and teleworker locations. So this is the end of this video lecture. Have a great day. See you on the next video.